All right, question 10 says, use the ratio test to determine the values of x so that the series, which is the sum of negative 2 to the n over n times x minus 3 to the n, and n starts at 5 here, converges. All right, so to apply the ratio test, we first note that a sub n is negative 2 to the n over n times x minus 3 to the n, and so a sub n plus 1 is negative 2 to the n plus 1 over n plus 1 times x minus 3 to the n plus 1. And so then to compute the ratio of a sub n plus 1 and a sub n in absolute value, as we have been doing, I'll go ahead and take a sub n plus 1, you see here in green, and multiply it by the reciprocal of a sub n, and then simplify. Okay, so negative 2 to the n plus 1 divided by negative 2 to the n, that's just going to give us a negative 2. N over n plus 1, since I'm anticipating the limit as n approaches infinity, I'm going to divide the numerator and denominator by n. And so this is equal to 1 over 1 plus 1 over n. So that goes in right there. And then x minus 3 to the n plus 1 divided by x minus 3 to the n. That's just x minus 3. Okay, now there is this absolute value here, so I can pull out the negative 2 and the 1 over 1 plus 1 over n. They come out as 2 over 1 plus 1 over n. But I have to leave the absolute value on the x minus 3, and that's because for certain values of x, this quantity x minus 3 is positive, and for other values of x, that quantity is negative. Okay, so this is our simplified expression. And so now for our value of r, which is the limit of this expression, I see that the 1 over n is going to approach 0, and so we get that r is equal to 2 times the absolute value of x minus 3. Okay, so now we have a few cases to consider. Okay, we know that if this number r is strictly less than 1, the ratio test implies that this series converges. Okay, so that's equivalent to saying that if 2 times the absolute value of x minus 3 is strictly less than 1, or in other words, x is strictly greater than 5 halves and strictly less than 7 halves, then we know that this series converges. And I've illustrated that on this number line over here. So I'm shading the values of x that will give rise to a convergent series as guaranteed by the ratio test in blue. Okay, now ratio test says that if this number r is strictly greater than 1, then this series will diverge. So that's equivalent to saying that 2 times the absolute value of x minus 3 is strictly greater than 1, or in other words, if x is strictly less than 5 halves or strictly greater than 7 halves, then this series will diverge, and I illustrate that here in red on the number line. And then the last scenario, this is where r is equal to 1, and the ratio test there is inconclusive. Okay, it does not tell us that for these particular values of x, 5 halves and 7 halves, whether or not this series converges. Okay, so I note here we have to check these values of x individually. So we can go ahead and do that here. So if x is 5 halves, okay, if I plug 5 halves in for x, x minus 3 is equal to negative 1 half. And see, this is going to give me then a negative 1 half raised to the n power. But see, I have a negative 2 to the n there, and so those are going to divide out, leaving me with just the sum of 1 over n, where n starts at 5. Okay, now this is divergent. You could just say that it's a p series with p equal to 1. Or you could also say it's really the harmonic series, where we're just missing the first 4 terms, but it will still, of course, diverge. All right, so we diverge when x is 5 halves. When x is 7 halves, well, now this quantity x minus 3 will equal positive 1 half, and so this gives me 1 half raised to the nth power. And so with the negative 2 to the n divided by 2 to the n, I'm just going to lose the 2 to the n, but I'll keep the negative 1 to the n. Okay, so now we're looking at the sum of negative 1 to the n over n, and n starts at 5, and this is a convergent alternating series, right? Because our b sub n here would just be 1 over n, and that's clearly decreasing, and it goes to 0. So it converges by the alternating series test. Okay, so to wrap that all up, we conclude that the series converges for x strictly greater than 5 halves and less than or equal to 7 halves. All right, that's going to do it. Thanks.